Good morning, grade 11. Now, inshallah, we are going to complete the previous session that we studied, which is thermochemical equation. And we said that thermochemical equation express the amount of heat released or absorbed by chemical reaction. Okay, so what is the function of thermochemical equation? Can you read? Can you read, Rakan?
Okay, Mr.
What about thermochemical equation?
Thermochemical equation
Yes.
expresses the amount of heat released or absorbed by chemical reaction.
It's okay. Thanks, my friend. After that, we are going to show our essential questions that we are going to explain this in our session. First, who can read? Khaled Habib. Khaled Habib, can you read the first question? Khaled Habib.
Yes.
Okay, Khaled.
Yes. How thermochemical equation
Yes.
of chemical reaction and other process were written.
It's okay. Written. Okay. Thanks, Khaled. Can you complete, Abdullah? The next question. Abdullah, can you read second question? Where is Abdullah? Abdullah? Okay, Abdurrahman?
Yes, Mr.
Can you read Abdurrahman second question?
Okay. How is energy lost or gained during change of state?
Okay, thanks, Abdurrahman. Al-Walid, can you read, please, Al-Walid? Third question.
How is the heat that is absorbed or released in a chemical reaction calculated?
It's okay, thanks, Walid. So vocab that we studied before, that we said combustion reaction. Combustion reaction, okay? But the new that you are going to study, okay, in this is the new. Hussein, can you read, Hussein, first two?
Vocabulary, new or review?
New, the first two.
Okay. Thermochemical equation. 2. Enthalpy, heat of combustion.
Okay, thanks. Khaled Harbi, can you read, please, the second two?
Molar enthalpy, heat of vaporization, and molar enthalpy, heat of fusion.
It's okay. Thanks, Khaled. After that, writing thermochemical equations that we explained before. Mu'taz. Abdullah, where are you, Abdullah? I said
الحمام والله.
Okay, but you didn't take a permission for me to know if you go to bathroom or not. Okay, Abdurrahman, please. Okay, Abdullah, no problem. But first, you can take permission for me, okay, to know if Abdullah is found in our session or go to bathroom. Okay, Abdullah.
خلاص معليش مستر بس ما كنت اقدر احطه.
Okay, thanks, Abdullah. Can you read, Abdullah, please, the first paragraph?
A thermochemical equation is balanced chemical equation that includes the physical state of all reactants and products and energy change.
Okay, thanks, Abdullah. Mu'taz, can you read second paragraph, Mu'taz, please? Mu'taz? Where is Mu'taz? Mu'taz, can you read second paragraph, please?
Yes, Mr. You
Yes,
put
Mu'taz.
me mute. The identify heat of composition
It's called enthalpy. Enthalpy.
enthalpy of composition of substance is the
Enthalpy
enthalpy change for the complete
burning
burning of one of 1 mole of the substance.
of substance. Okay. It's called enthalpy of combustion of a substance is the enthalpy change for the complete burning of 1 mole of substance. Okay, thanks, Mu'taz. Okay. After that, this is the standard enthalpies for combustion as we studied before. After that, molar enthalpy. Molar enthalpy. Okay, Musa. Can you read Musa, please?
Molar enthalpy of vaporization.
Yes.
Refers to heat required to vaporize 1 mole of a liquid substance.
Yes, good. Thanks, Musa. Nasser, can you read molar enthalpy of fusion? Nasser,
Yes, Mr.
can you read, please? Molar enthalpy of fusion?
Okay, molar enthalpy of fusion is the amount of heat required to melt 1 mole of a solid substance.
It's okay, thanks. So you must take care that vaporization means vaporize. Vaporization means vaporize 1 mole. But fusion means melt 1 mole. So it's difference between them. You must take care from these words because these words, okay, determine if this is molar enthalpy of vaporization or molar enthalpy of fusion. Okay, guys, this is the standard enthalpies of vaporization of and fusion. After that, change state. In this phase change, okay, in this phase it change. What about this phase change? Okay, this is delta H fusion, meaning melting, okay. H2O is solid. H2O is solid as its ice. Okay, solid as what? As its ice. So it's called what? It's called that it's ice or water in its solid state. Okay, delta H of it equal negative 6.01 kilojoule. Okay, then then is a fusion to increase to be liquid. Okay, then after beginning liquid, delta H of vaporization. That positive means that absorbs. Okay, take care from these words and these signs. Positive means that it will absorb amount of heat energy. Absorb amount of heat energy, but in the opposite direction. In the opposite direction. Negative means what? Negative means that it will release amount of energy or produce amount of energy. So it's the difference between the positive and negative. Okay, so positive means what? Positive means that it will absorb amount of energy, while negative means that it will release or produce amount of energy. So it's the phase change of water, okay, and this enthalpy from being water in a solid state, okay, so liquid state, so gaseous state. Okay, Khalid Harbi. Okay, Khalid, what do you need, Khalid?
Mr. KJ represent what?
kg means kilojoule. It's a
Kilojoule.
unit. It's a unit of delta H, unit of amount of energy, kilojoule. It's okay?
Okay.
It's okay, Khalid. After that, after the change, K of energy, then say the endothermic and exothermic reaction. Okay, how flow in endothermic and exothermic reaction. Okay, listen please. Listen to this video.
consider the
Listen, please.
diagram where the universe is represented as the system and surroundings. The system is the specific part of the universe that is of interest to us. In this case, the system is the block of ice. The rest of the universe, outside the block of ice, is called the surroundings. In this animation, both macroscopic and microscopic views of ice are shown. Let's show a transfer of heat from the surroundings to the system. At 0 degrees Celsius and a pressure of 1 atmosphere, ice melts to form liquid water. To melt a solid, attractive forces around the particles must be overcome. As heat is absorbed by the solid, particles begin to move about more vigorously, and some particles break free from the attractions of neighboring particles. Measurements show that for every mole of ice converted to liquid water at 0 degrees Celsius and a pressure of 1 atmosphere, 6.01 kilojoules of energy is absorbed by the system, the ice, from the surroundings. When heat has to be supplied to the system by the surroundings, the process is called an endothermic process. Click on the button below to look at the reverse process, the freezing of water. At 0 degrees Celsius and a pressure of 1 atmosphere, liquid water freezes to form ice. As heat is removed from a liquid, the motion of the liquid particles slows down so that stronger attractive forces in the solid can form between the particles. Measurements show that for every mole of liquid water converted to ice at 0 degrees Celsius and a pressure of 1 atmosphere, 6.01 kilojoules of energy must be given off by the system to the surroundings. When heat is transferred from the system to the surroundings, the process is called an exothermic process. Click on
Understand this video, guys? Understand this video? Okay. This video about including the large amount of energy which was absorbed and released during changing water from solid state as ice to liquid state as water to gas state as water vapor. It's okay. Understand this? Any problem? Okay. We are going to complete. Okay. We are going to complete our session. So after this video, this is a problem. A bomb calorimeter is useful for measuring the energy released in combustion reaction. The reaction is carried out in a constant volume bomb with a high pressure of oxygen. How much heat is evolved when 54-gram glucose, which has simple C6H12O6, is burned? According to this equation, or the equation C6H12O6 solid, which is called glucose sugar. After burning, so burning means plus O2. Burning means plus O2. So C6H12O6 solid plus 6O2 gas state to produce 6 CO2 gas, which is produced from burning, plus 6 H2O in a liquid state. And delta H of combustion equal negative 2,808 kilojoule. Okay. After that, you are given the mass of glucose in this reaction. For the combustion of glucose and delta H combustion, you must convert grams of glucose to mole of glucose, because the molar mass of glucose is more than 3 times the mass of glucose burned. You can predict that the energy evolved will be less than 1/3 of delta H, as known mass of glucose and delta H, but unknown Q. How can we get it? Q. Convert grams of C6H12O6 to moles by this C6H12O6 How can you get this moles? As we said before, okay, mass of substance divided by molar mass. Mass of substance, okay, mass of substance 54.54.0 divided by molar mass of glucose, which will be 180.18. And we studied and explained before how can we get the mole of substance. Mole of substance. Mass of substance, which is 54, divided by molar mass of the substance. Molar mass of glucose sugar equal 180.18. So this divided by this equals 0.300 mole. So it's the number of moles. Okay. After that, multiply moles of C6H12O6 by enthalpy of combustion as multiply moles of glucose by 2808 divided by 1 mole. Okay, so equal what? Equal 0.300 times this 2800.8 over 1 equal 842 kilojoule. Okay, so after that, this is the answer of this problem. Okay, all value in the calculation have at least 3 citation figure. So the answer is correctly stated with the 3 digits. As predicted, the released energy is less than 1/3 delta H. Okay. After that, combustion reaction. What's meant by combustion reaction? I said before that combustion means reaction with oxygen. Combustion means reaction with oxygen. So combustion is the reaction of a fuel with oxygen gas. Food is a fuel in combustion reaction in biological system. Food is a fuel. Okay, we can't move without eating. Okay, we can't move without eating. Especially, we will observe this in Ramadan, inshallah. Okay, as you must get food. If your stomach, has no food, so you will observe, you will feel that you are weak. Okay, that you are not strong to carry things, to move, to make any activities. Why? Because there is no fuel. Fuel of our biological system is food. So food for humans similar to benzene for cars. Okay, so food is a fuel in combustion reaction in biological system. Okay, after that, this is the what we studied before. Okay, this is the stuff what we studied, essential question. Okay, that we studied. How are thermochemical equation for chemical reaction and other processes written? How can we written? How can we write them? How is the energy lost or gained during changes of state? How is heat that is absorbed or released in a chemical reaction calculated? Okay, and the vocabs that we studied in this session: thermochemical equation, enthalpy, heat of combustion, molar enthalpy, heat of vaporization, molar enthalpy, heat of fusion. Okay, so we end our session now, but now we are going to what? Now we are going to return to Magro Hill, okay, to take question about the lessons that we studied, okay? Now, who can answer the first question? Can raise his hand. And this is a problem. Khalid, okay, Khalid.
I will try, Mister.
Yes, well, try because it's a problem.
How much
you
heat?
must have calculator. If you have no one,
Yes.
okay, you must say steps only.
No, I have.
It's okay.
How much heat is involved when 27 grams of glucose is burned according to the equation? First, we convert grams to moles.
Yes, good.
We multiply 27 multiplied by 1 over 180, I think.
Yes, it's the molar mass of glucose sugar.
27 1 over 180.18 will be equal 150 over 1001.
Okay.
Then we multiply the mole by the enthalpy of combustion.
Yes.
Which mean 151 over 1001 multiplied by negative 2808.
Yes.
Will give us the answer is totally different. It gives me a negative number.
What is the number?
423.
423. Okay.
Negative.
Okay, we are going to know the best answer at the end of this. Okay, but now the nearest answer is 421 kilojoule. Okay, but at the end of this quiz, we are going to know the best answer. Okay, thanks, Khalid, for your participation. Okay, second one. Who can answer second one? Who can answer second one? Sin?
Yes, Mister.
Yes, Hussein, can you answer second one? This is the hint. If you need a hint,
Calculate the amount of
the problem is 3 parts.
Okay. Calculate the amount of heat absorbed by 10 grams of ice at negative 15 degrees Celsius as it is converted to liquid water at 15 degrees Celsius. The specific heat of H2O as solid equals 2.09 joule per gram degree Celsius. The specific heat of H2O as liquid equals 4.18 joule over gram degree Celsius.
Yeah.
The molar enthalpy heat of fusion is 6.01 kilojoule per mole.
Yeah, so it needs Q, amount of energy absorbed.
Okay. We first convert the grams into moles.
It's okay.
So we get
H2O
by 10 over 16 times 18.
Yeah.
So let me use the calculator. So we have 0.555 moles.
It's okay. After that?
Can I use hint?
And includes that this problem has 3 parts. This is the hint. Do you see it?
Nope.
See it?
No, I can't.
It's okay. This is the hint.
Okay, here it is.
This problem is 3 parts, okay?
Okay.
It's okay. Return to our question, okay?
So the first part is the specific heat of H2O as solid.
Yes.
So for each gram, okay, we have 2.09 joules of each gram in each Celsius degree. So from negative 15 to 50, there are 65 degrees.
Yes.
Okay. The second part is to convert it to.
Okay, so excuse me, Hussein.
Yes.
Can you choose now any answer, and after finishing quiz, we are going to know the best answer to don't waste the other question, because our session has 4 minutes only and end. Okay.
Okay, choose anything.
Okay. Any answer at this? Thanks, Hussein, for your participation. Question number 3. Walid, can you participate with me? Walid. Walid, question number 3.
Hello.
Hi, Walid. Okay. Can read question number 3.
A fuel is found to release 3,280 kilojoules of heat. When 0.600 moles of the fuel is burned, which of the fuels listed in the table is most likely to be this fuel?
Yeah, which of the fuel listed in the table is the most likely to be the fuel?
Glucose.
Glucose. It's okay. Glucose, which is saccharose. It's okay. Thanks, Wade. Another question. Okay. Musa, can you answer it, please, Musa? Question number 4.
Yes, Mister.
Okay, Musa, can you answer it, please?
I will try.
Okay, try.
Spraying ethanol on your hand makes your hand feel cool. How much heat is absorbed in turning 3 grams of ethanol from liquid to a vapor?
Okay, so ethanol has simple C2H5OH. And delta H, vaporization, 38.6. And delta H fusion equal 4.994.
Maybe it's C.
It's okay. We are going to know the best answer at the end of our quiz. Thanks, Musa, for your participation. Okay, the final question. Nasser, can you participate with me, Nasser, in the last question?
Yes, Mister.
Okay, Nasser?
Okay, number 5?
Yes, last question.
Okay. A hydrogen balloon contains 0.25 moles of hydrogen gas explodes in the presence of oxygen, such
Yes.
that all the hydrogen reacts. How much heat is released?
Yes.
Mister, I'm sorry, but I don't have a calculator.
Okay, so you can choose any question. Okay, and after finishing this, we are going to know the best answer.
What? I don't understand.
You can choose any question, any answer, and after finishing the quiz, we are going to choose the best answer.
140, 286
Okay.
kilojoules.
Okay, 286 joules. Okay, now
Yes.
we are going to know the best answer. First, as Khalid Harbi said, it's true, Khalid. Thanks, Khalid. Second, Hussein. Okay, this is the answer. This is the best answer, Hussein. Question number 2. Okay, part including temperature of ice from -15 to 0. Heat equal mass times specific heat times temperature. Okay, so it's the best answer. Okay, it's the best answer to be 5.73. You can return to McGraw-Hill and know the answer. Okay, Hussein? Question number 3 would be octane, Walid, not glucose. Musa will be octane. Okay, Walid, it will